Okay guys, so this is what's called series and segment notation, okay? Actually, sorry, before that, a series. A series is a sum of numbers. Now, sum means adding them all together, where each number after the first is formed by some definite rule. Sn represents the sum of the first n terms. So for example, if a sequence is 1, 4, 7, 10, then the series is 1 plus 4 plus 7 plus 10 plus all the other numbers. The commas are replaced by plus signs to form the series. The sum of the series is the result of adding the terms. The sum of the first n terms of a series is denoted by Sn. Sn is basically adding all the first n term series. So for example, if I said S5, S5 would be adding the first 5 numbers together. So you get 1 plus 4 plus 7 plus 10 plus 13. N, we're assuming that n is a big number, and it doesn't always have to be, and there's lots of missing terms in between, so we couldn't possibly write down all the numbers of, let's say for example, S100. It'll take a long time. So even though each term is separated by a plus sign rather than comma, we will write T1 equals 4. Okay, so T1 equals 4, T2 equals 7, T3 equals 10. Okay. But actually I think that's a small mistake there. I think if you look at this carefully, T1 is 1, T2 is 4, T3 is 7, and T4 is 10. Okay, so for example, S1 is the same thing as T1, so S1 is 1, T1 is 1. S2 is 1 plus 4, which is 5, and that equals T1 plus T2, which is 1 plus 4. S3 is 1 plus 4 plus 7, which is 12, and that equals 1, 4, and 7. Okay? And likewise, Sn will equal T1 plus all the way up to Tn. Okay? Or Sn minus 1 will be T1 plus all the numbers up to Tn minus 1. Okay? Now, series and segment notation. A finite series is one which ends after a finite number of terms. So example would be this a series that only has 20 terms, goes all the way up to T20 and ends. Okay, the sum of the n terms of a series is denoted Sn. We went over that already. This is an example of a finite series since there's a finite number of terms. The finite series Sn can be expressed more concisely using segment notation. So Sn is the same thing as n on top r equals 1. So this r equals 1 means we start off at T1, and then Tr represents all the numbers. Okay. So what it represents is that the fact that the first term 1 is the same as here, and the last term n is the same as the one here. The letter r, or called a dummy variable, does not appear when UR is written out. So UR, R just disappears into U1 plus U2 plus U3 plus UN. Okay, you can see in this time, instead of having T, we have U. So T and U, there can be all types of different letters. So for example, we can do another one that has N on top, I on the bottom, and U to the power of I. So this time we're just going to be doing U1, U2, U3, U4. Or we can do K on the bottom. So the dummy variable, this letter has no real significance. This one here is the last number you're going to be doing. So the 1 is the first, means you start off at T1, and N means just the end at Tn. Okay, so we can see that it's all like, it can be written 7 different ways. Okay, now, so basically in a nutshell, this is the last variable of the sequence. This is the first variable of the sequence, and UR is the general term, which means you start off with U1, U2, all the way up to U20. The dot 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 indicates more terms. Okay? Now, in this one here, we have the last term is not n, it's infinity. Infinity means it has no end. The first term is 1, so UR is going to be U1, U2, U3, U4. It's going to go all the way up, and it never stops. Okay, so this never stops, and this indicates a series that just continues on and on. Okay, notice that so sometimes you're going to have something like this. Okay, so an example would be let's say for example this one here, which is question 6. Okay, so question 6 has the following. What we need to find out is r equals 0, so it means it starts off at r equals 0, and it's 1 minus r to the power of r. Okay, So what we can do here is we have to find out what are the sum of the first 6 terms. Okay, so the first 6 terms. Now, if you have minus 1 bracket r, okay, when r is even, you're gonna get out a, this is gonna turn into a number 1. When it's odd, it's going to be a minus 1. Okay, so an example would this be question 6. Okay, so we're asked to find the total amount is. So what we can do here is we can find out what t1 is, or t0. Now t0 is going to be minus 1 to the power of 0 to the power of r, or to the power of 0. And what we're going to get is both of them are going to be 1. So it's just going to start off at 1. Okay, t1 is going to be minus 1 to the power of 1, and then you're going to have 2 to the power of 1. And what we're going to get here is minus 2. t2 is going to be minus 1 to the power of 2 to the power of 2, which is going to be 4. t3 is minus 1 to the power of 3 to the power of 3, which is minus 8. t4 is going to be minus 1 to the power of 4 to the power of 4, and that's going to be 16. So we can see what's happening here. Double and change sign. So double, next one's going to be minus 32, and the one after that is going to be plus 64. So t5 and t6. You could also maybe even try your luck on a calculator, where you could say, look, do a table, and then you can do minus 1 to the power of x, and then we're going to go 2 to the power of x, close it down. Okay, so minus 1 to the power of x, 2 to the power of x, and then you can do it from 0 to 6 in a step of 1. And look, same answers: 1 minus 2, 4 minus 8, 16, 32, 64. Now remember, this means the sum, so I have to add them all. So it's going to be 1 plus minus 2 plus 4 plus minus 8 plus 16 plus minus 32, and then finally plus 64. Again, this is all question 6. And then the answer to this question is going to be, so question 6, the answer is going to be 43 when you put all that into your calculator. So that's how that type of question can work. Okay, so that's question 6 done. Now, other things that you can be asked is finding Tn, so finding any term when you're given Sn. So for example, S4 is T1 plus T2 plus T3 plus T4. S3 is T1 plus T2 plus T3. Therefore, S4 minus S3, and then you take away all the terms you have in common, and what that will leave is T4. So T4 equals S4 minus S3. An example, T5 is S5 minus S4. And then finally we can say that Tn is Sn minus S of n minus 1 for all series. Okay, so we've already done question 6. Now we're going to move on to try question 3. Now once again, question 3 here can be done the same way as last time. So we can have we need to find out what T1, T2, T3 is. Okay, so T1 is going to be 1 squared, 2 squared, we're going to have 3 squared. T4 is going to be 4 squared, T5 5 squared, and T6 is 6 squared. So you're just going to have 1, 4, 9, 16, 25, 36. Add them all down together, and what you get when you add them all down together, we're going to get basically 91. Okay, so that all adds up to 91. So the answer to the first one is 91. Get the sum of all the terms added together. Okay, because you have to square each one. The starting one is 1 and the end is 6. Okay, now we're going to move on to question 8. Now question 8 is very similar to question 1. So what you can say is that we're starting off at T3 and we're going to end up at T7. Okay, so we're going to have T4, T5, T6 and T7. Now we have to figure out what all these numbers are. Now you might think about inputting them all in individually, but what we could do is, once again, we could just try out something like this. So minus 1 to the power of x, I probably need to put all of that. Okay, so let's make it look exactly as it is. Okay, so we're going to have a bracket here, minus 1 to the power of x. I'll just save it doing them all individually. And then we're going to have x minus 1 on the bottom. I'm just changing x with r, same thing, okay? Now, we start at 3, we end at 7, step of 1, and what we're going to have is a half, minus a half, a third, minus a quarter. So it's going to be minus a half, a third, minus a quarter, then go again. We're looking at 0.2, which is a fifth, and then the next one should be minus a sixth, which is minus 1.666, so minus a sixth. Okay, how do we do that? For example, let's take T6 as an example. Minus 1 to the power of 6 divided by 6 minus 1. Replace all r's with 6. We're going to get 1 over 5. Okay, so we just did that a couple of times. Now we've got to add them all together. So what you're going to do is you're going to add all of these together. Keep in mind the excuse me. So keep in mind the minus sign. Okay, so we're going to add all these together, and when we add all these together in the calculator, what we should get, if I'm not mistaken, will be minus 23 over 30. Sorry, minus 23 over 60. So you're going to put all of these in the calculator. Minus a half, plus a third, minus a quarter, plus a fifth, and minus a sixth, and what you'll get is minus 23 over 60. Okay, moving on to question 12. Okay, for a sequence un where un equals n by n plus 1, find S3. Well, S3 is basically u1 plus u2 plus u3. So we just got to find out what u1 is. u1, put in 1 and we get a half. u2 is going to be replace n with 2 and we're going to get 2 over 3. And then u3 is basically replace n with 3 and we get 3 over 4. We're going to add them all together. A half plus 2/3 plus 3/4. And when we put a half plus 2/3 plus 3/4 in, what we should get is basically, so this is question 12, we should get 23 over 12. Okay, so this is 23 over 12. Very simple question, okay? Now question 16. For a series Sn equals T1 plus T2 plus Tn, where Sn is n over n plus 1 over 2. Find S of n minus 1. So S of n minus 1 is basically replace all n's with n minus 1. So we're going to have n minus 1, and then in here we're going to have n minus 1, and then in the bracket we're going to have n minus 1 plus 1, and that just turns into n all over 2. That's going to get me is n squared minus n all over 2. Okay, now once we define Tn, so I'm also going to multiply out what Sn is, so it's going to be n squared plus m all over 2. Okay, so what we need to find out is this is number 16. Okay, so we know what S of n minus 1 is, it's this answer here. And now we're going to find out what Tn is. Now Tn, as we discussed earlier, Tn is Sn minus S of n minus 1, in the same way that T4 equals S4 minus S3. Okay, so what we're going to do is put in S of n, which is going to be n squared plus n all over 2. And then the other one is going to be minus brackets n squared minus n over 2. So they have the same denominator, So all over 2, put the number 1 in here, multiply it out, we're going to get n squared plus n minus n squared plus n. N squared is cancelled, 2n over 2 gives me n. So the answer for this question is n. Now, once we find out what n is, now we have to find out what t20 is. Okay? Now t20 is the same thing as t20 can be done two ways. T20 is going to be S20 minus S19. So we could do this two different ways, okay? Well, we already know that Sn minus Sn minus 1 is n. So therefore, if I replace, that's what Tn is. Tn equals n. Therefore, T20 must equal 20. So the answer is in fact 20. Now, if you wanted to do a different way, what you could say is that T20 is S20 minus S19, and S20 is the same thing as 20 squared plus 20 divided by 2, which is going to be 420 divided by 2, which is 210. Okay, and then you have to find out what S19 is, which is going to be 19 squared plus 19 all over 2. You check what that is in the calculator. So 19 squared plus 19, divide that answer by 2, and we see that that's minus 190, and then once again we can find out that that's 20 as well. Okay, so that's number 16. Now we're on to number 19. Okay, so what we find out here is that S of n is n times n plus 1 times n plus 2 over 6. Using simpler notation, or otherwise evaluate basically 10 r equals 1 tr. So this basically means I need to add up the first 10 terms. I need to find S10 so that such that it's equal to T1 plus T2 plus dot 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 all the way up to T10. Okay. Now, surely these guys should be the same one. So I'm just going to take I'm just going to replace n with 10. So you're going to get 10 times 11 times 12 all over 6. And what I should get here is 110 multiplied by 12, divide that by 6, and what we get is 220. So the answer to the first one is 220. Okay? And then it goes, hence or otherwise evaluate 20 as r equals 11 tr. Well, I'm probably just going to now this is an interesting question, okay, because S10 is T1, T2 all the way to T10. This question here is really specific to T11 plus T12 all the way up to T20. Alright? So this is what I'm looking for. This is the question. I want to find out what is T11 all the way up to T20. Okay? And then if I look very specifically at what S20 is, so if I did S20, and S20 will be the equivalent of r equals 1. You have to start off at r equals 1, end at 20, tr. That would be T1 plus T2, dot dot dot, plus all the way up to T20. So you can see that the difference between S20 and S10 is going to be, S10 is missing 11, 12 all the way to 20. While S20 includes all the numbers from 1 to 20, all the terms from term 1 to term 20. So this one here is basically S20 minus S10. Okay, so we know that S10 is 220, so now we have to find out what S20 is. So S20 means replace all n's with 20s, so it's going to be 20 times 21 times 22 all over 6. So 20 multiplied by 21 multiplied by 22, divide that by 6, and we get 1,540. Then take away your 220. Oh, wait a second. To divide that by 6, yeah. And then you're going to take away your 220. And when you take away your 220, what you should get is 1,320. There you go there, 1,320. Okay.